so I remember. So this is section 4.2, and it's about the unit circle. Okay, so if you remember last class, we were talking about if I had any point if I had an angle and it was in the XY plane and we found some point on it, so, here is my angle theta. Last class we talked about how you would draw this reference triangle, and you have an X value and a Y value, and this point is X comma Y, and the hypotenuse is R. And if you remember, we talked about how the sine of theta was Y over R, the cosine of theta was X over R, the tangent of theta is Y over X, and then we flipped them over, right? So the cosecant of theta is R over Y, the secant of theta is R over X, and the cotangent of theta is X over Y. So that's what we were talking about last time. This time we're going to kind of build on that. And this time we're going to talk about finding the values of trig functions on what's called a unit circle. So when you hear the word unit, what do you think of? Okay, a whole. Yep. Anything else? What about if you had to guess a number? If I said something is a unit, what would you guess? What number? Okay, a group. What number if I said, oh, that's a unit long? What number would you guess I might be talking about? Yeah, 1. And so that's what actually the unit circle is. So the unit circle, all the unit circle is a circle of radius 1. So the idea here is, so I have a circle and this radius here is 1, right? So the distance from the center here out to here is 1, which means this point here is the point 1, 0. Right? 1 on the X, and I'm not moving anywhere on the Y. What would this point up here be? -0, 1. What about this point over here? -1, 0, yep. And what about this point down here? Yeah, 0, -1. Okay, so these points, right, they correspond to angles. So if I am here and I haven't moved at all, my angle is actually 0 degrees or 0 radians. We could write it either way. So we could write it as 0 degrees or we could write it as 0 radians. So if we wanted to find, say, the sine of 0 degrees, so remember we said sine is the Y value over the R value. So in this case, Y is 0 and our, okay, so why are my pencils charging here for a second? I have 0 over 1. And so the reason that I got 0 over 1 is because the distance here, the radius, was 1. And this is kind of weird because it's kind of like I have a triangle, but my triangle doesn't have any height to it. So it's kind of weird when you're on these main spokes here because you're talking about triangles that don't actually look like triangles, and that's very odd. But the idea is that as I go out here on the unit circle, anywhere on the unit circle, that radius r from over here is always going to be a 1. So what's really nice is on the unit circle, if I'm looking for the sine value, what my r is always going to be a 1, so I'm always dividing by 1. So my sine value is actually just the y value. So 0 divided by 1 is actually just going to turn out to be 0. If I was looking for the sine value here, we would have 1 divided by 1, and 1 divided by 1 is also just 1. If I was looking for the sine value over here, we would have the y, which is 0, divided by 1, so it's just 0. And then here, it would be minus 1 divided by 1, which is just minus 1. So the unit circle is really special because on the unit circle, if you're looking for the sine or the cosine, it's just the x or the y value. And that's the only part you really need to remember in terms of finding stuff off the unit circle is how to find the sine and the cosine. Because if you can find the sine and the cosine, we can find all the other trig functions. So, we're going to look at that here in a minute. So, just give me a second. I just want to make sure that my pencil gets enough juice for the rest of class. So, while we're paused for a minute, does anybody have any questions so far? It charges pretty quick. I just completely forgot to look at the charge before class. Also, after class, I'm going to put a couple of handouts up into the handout section of our course so that you can go in there and look at those. So I have a handout of the filled in unit circle. Once we're going to fill it in, develop it here ourselves. I'm also going to link to a YouTube video which is not one that I made, so it's one somebody else made. That actually shows you how to use your hand to help you memorize the unit circle. So the unit circle is something that you need to have committed to memory for the first test. So, yep. Yeah, so you're basically just finding x or y depending on whether they're asking for the sine or the cosine. So if they're asking for the sine, we're just pulling off the y value. If they're asking for the cosine, we're just going to pull off the x value. And I'm going to do a bunch of examples to show you this. The first thing I'm going to do is I'm going to kind of show you where some of the things in the unit circle come from, and then we're going to go from there. All right. So we're probably good here for a while. Okay. Let me finish writing this here. So, whoops. 0 divided by 1 is, in fact, 0. So, on the unit circle, the sine of theta is equal to the y, and the cosine of theta is equal to the x. And the reason why is because that r value is 1. And if you divide anything by 1, it doesn't change anything. It just leaves it what it is. Questions so far? No? Okay, so now, let me add in here. Okay. So this is what the big unit circle is going to look like. And we just filled in some of these points, right? We just said that this point here was 1, 0. And this point here was 0, 1. We said that this point here was minus 1, 0. And this point was 0, minus 1. And we talked about how this is 0 degrees, or it's also 0 radians. So this straight up and down one here, how many degrees am I if I went from here to here? Right? I'm making a right angle. So how many degrees am I here if I've rotated in my unit circle to up here? 90, right. Okay, so 90 degrees. Now, we've already gone through how you can convert from degrees to radians, right? So 90 degrees is actually, if you were to multiply it out and convert, it's actually pi over 2 radians. It is helpful to just remember to remember that 90 degrees is equal to pi over 2 radians. So that is a helpful piece of information in terms of the unit circle. So that would be 90 degrees. If I go another 90 degrees, I'd be over here at 180 degrees, or pi radians. And if I went another 90 degrees, I would be down here at 270 degrees, or 3 pi over 2 radians. So I think of these 4 spokes here that I'm doing in pink, I think of these as the pi over 2 spokes. So every time I move on one of these spokes, I'm moving a pi over 2. So I'm not going to fill in this whole unit circle here. In a minute, I'm going to put up a filled in unit circle. But I kind of want to show you where the values on the unit circle come from, where some of them come from. So let's look at this spoke here. So this spoke here is actually 45 degrees. And 45 degrees, if you convert it, is the same as pi over 4. So knowing some of these key degrees and their conversions to radians will actually make your life in trig easier. So the ones you kind of want to remember is that 90 degrees is pi over 2, 45 degrees is pi over 4, 30 degrees is pi over 6, and 60 degrees is pi over 3. Now, I think it's helpful if you memorize them. You don't have to, right? Because you can always take the degrees and convert it to radians by multiplying. Remember, we did that by multiplying by pi over 180. So you can go back and forth. But just in case, like, it's helpful if you kind of drill into your head, 45 degrees, pi over 4. 30 degrees, pi over 6. 60 degrees, pi over 3. Okay, so we want to think about, I have a point here, and we know that the length of this green line I drew was 1, right? Because it's a radius on this unit circle. So all the radii on the unit circle are a length of 1. And I'm going to drop a line down to make here a right angle. And so we talked 2 classes ago, I believe now, about the special right triangle. That was the 45, 45. Oh, that's terrible looking. I have this unit circle blown up so big that it's making my pen then have to be really big. Okay, so we had a 45, 45, 90 triangle. And in this 45, 45, 90 triangle, we said before that the sides were x, x, x root 2. Does that ring a bell? Okay. So, in my problem here, I have a triangle, and it's a 45. So, in here, this angle here we're saying is 45 degrees, which means this angle is also 45 degrees. So, I have this 45, 45, 90 triangle. I happen to know how long the hypotenuse here is. So the hypotenuse happens to be a 1, which means over here I know that x times the square root of 2 would have to end up being equal to 1. And I want to figure out what x is. So x square root of 2 has to be equal to 1. If I divided both sides by the square root of 2, oh, I see what's happening down here. Erase those things. x ends up being equal to 1 over the square root of 2. 1 over the square root of 2 I could rationalize. I know I said we usually don't rationalize, but the values you're going to see on the unit circle are actually rationalized. So to rationalize, you multiply by root 2 over root 2, and that would end up being 2 over, would end up being root 2 over 2. Which means this side here of my triangle, of this green triangle, is root 2 over 2. And this side here of my green triangle is root 2 over 2. Which means these 2 points here are root 2 over 2, comma, root 2 over 2. So, all of the points on the unit circle come from looking at these special right triangles. So we had the 45, 45, 90 triangle. We also had the 30, 60, 90 triangle, and that's where some other ones come from. We could do the same thing with this spike here. This is actually 30 degrees. I'm not going to do it all out because my pictures can get super messy. But that spike there is 30 degrees. And you could drop it down, and then you could do the same thing, figure out what the relationship is. And then if you work that out, you're going to see that this ends up being square root of 3 over 2, comma, 1/2. So, I want to kind of show you that, like, there is a method to where all these numbers come from on the unit circle. They all come from making these triangles, dropping the triangles down, and filling the stuff out. So I say that because on this next slide here, I'm going to go to in a second, I'm going to put in the unit circle, and I don't want you to think I just pulled it out of thin air. It does come from making all these triangles. I'm just not going to draw all these triangles to show you every single value comes from. So before I just pull up the unit circle, questions? No? Okay. So, the unit circle. Oops. Okay. So here's a nice, pretty unit circle. See, I think I could. Probably, actually, wait a minute. Let me add it again. I think when I add it, I actually can make it bigger. Okay. So here's a pretty unit circle. You'll notice it has the points, right? Here are all these different points. It has the degrees, so 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. It has the radians that correspond to those degrees. Everything on the unit circle deals with a 30-degree angle, a 45-degree angle, a 60-degree angle, or a 90-degree angle as a reference angle. So, say that again? No. Okay. So, all the angles we care about, I'll say, on the unit circle have 30 degrees, 45 degrees, 60 degrees, or 90 degrees as reference angles. Again, on the unit circle, like on the unit circle, r equals 1. So as we said before, the sine of theta is just going to be the y value, and the cosine of theta is just going to be the x value. And unfortunately, you just have to memorize the unit circle. On the next test, or on the first test, I should say, there will be questions dealing with the unit circle. There will be potentially parts of the unit circle you have to fill in. So you need to commit the unit circle to memory. My students in calculus who struggle the most are some who don't know their unit circle. So when you get to calculus, you're just expected to know a lot of stuff off of the unit circle, which we're going to learn this semester. So I would take the time to learn the unit circle now. As I said, there is a hand trick. And essentially what the hand trick does is, which is, I'm going to post a video because it's not, you're watching me do it this way. But if you think about it, I could line up my hand with, I could put my thumb here and then my first finger, my second finger, my third finger, my pinky finger, right? On this first quadrant of the unit circle. And what I could do is if I put my middle finger down, right? If you'll notice on the unit circle, all of the bottoms here are 2, right? 2, 2, 2. And so when I put my finger down, the numbers below give me the y, and the numbers above, the square root of the numbers above give me the x, and the square root of the numbers below give me a y. So here I have 2 fingers above this finger that's pushed down, and 2 fingers below this finger that's pushed down, and that's where you get this root 2 and a root 2, right? If I were to put down this finger, so I'm putting down this finger, right? I have 1 finger underneath, so the square root of 1 is 1, and I have 3 fingers up above, so the square root of 3. So that's where those numbers come from. It even works on the ends. If I put my pinky down, so I put this one down, below it I have none. I have no fingers, right? So that 0 comes from root 0 over 2, which that just turns out to be 0. The 1 comes from, I have 4 fingers up above it. 1, 2, 3, 4, right? If this is the one that I've turned down, I have these 4 fingers up here. And so if you look at root 4 over 2, well, the square root of 4 is 2, and so you have 2 over 2, which is just 1. So that hand trick helps you memorize it. It's kind of hard because I can't actually physically put my hand over the unit circle, like in this environment. That's why I'm going to post the video for you guys of it. But the unit circle is the hand thing is very helpful to help you get the first quadrant of the unit circle. And then the thing to notice is that every point on the unit circle, here I'm going to erase my hand, has a matching point. So for instance, if I look at pi over 3 matches up here with 2 pi over 3. The only difference is here I have 1/2 square root of 3 over 2, and here it's minus 1/2 square root of 3 over 2. So as I move from the first quadrant to the second quadrant, the only difference between the first quadrant and the second quadrant is all of these x values are negative. The difference between the second quadrant and the third quadrant, again, these mirror over and reflect, but now all the y's become negative as well. And then they can go over and reflect again, and now the x's are back to being positive. So if you know one point, if you know the points in the first quadrant, you can actually usually reflect them around to get the other points. Questions? No. Okay, so let's put this into, can we do examples? Oh yeah, we're gonna, on how to calculate those numbers. So let me do some examples of just using the unit circle, and then let me see if that answers your question, and then if that doesn't, I'll come back to it again. Other questions? Yeah, you want to know. So very quickly, our course is going to transition into we're like almost exclusively going to use radians. We actually don't use degrees that often. There's like one section towards the end of the semester where we will use degrees again, and degrees are like the more standard thing. But for the vast majority of the rest of our course, we're going to be using radians. Other questions? No? Okay. All right, so I'm going to add that unit circle back in here one more time, so, and kind of keep it up here for us to use it. Okay, so for example, find the exact value, find the exact value of A, the sine of 180 degrees. Okay, so remember, we said, so I usually like to write myself a little note, right? So sine of theta is equal to the y, cosine of theta is equal to the x. So what would the sine of 180 degrees be? Yeah, 0. So I go to 180 degrees on the unit circle. I look at the y value. The y value here is 0. So the sine is 0. B, the cosine of 315 degrees. So what do we think about the cosine of 315 degrees? Okay, someone said 1. Someone said square root of 2 over 2. Okay, so let's look at this. So 315 degrees. Here's 315 degrees, right? I find 315 degrees on my unit circle. Here it is. I look here. I have root 2 over 2 minus root 2 over 2. So I'm looking for the cosine is the x value. So in this case, it's just root 2 over 2. Does that make sense? All right, let's try another one. What about the tangent of 210 degrees? So we didn't, I didn't write down the tangent before, right? So before we do this, we want to kind of talk about the tangent a little bit. So remember, the tangent of any angle we said before was y over x. So that still holds here. I have a y value, I have an x value. So if we're looking for the tangent of 210 degrees, we're going to take the tangent, we're going to look at the y value and the x value at 210 degrees. So if I go here to 210 degrees, the x value is minus root 3 over 2. The y value is minus 1/2. So I want y over x. So it's going to be minus 1/2 divided by minus root 3 over 2. Now, you can't leave your answer that way. We actually have to work out what that is. So remember, if I'm dividing fractions, we use keep, change, flip, right? So keep the first fraction, so minus 1/2. Change from division to multiplication, and flip the second fraction. So minus 2 over root 3. So minus times a minus will give us a positive, so the negatives are going to go away. And then on my 2's here would cancel each other out. So this is just going to be 1 over square root of 3. And you can leave it that way as 1 over square root of 3. If you want to rationalize it, you can, but you don't have to. Questions?
I have a question. I'm confused about why sine is y and cosine is x.
So if you remember last class, right, we talked about how So when we started way back when, like a week ago, right, we talked about how sine of some angle is opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. Do you remember that?
Yeah.
Okay. So if you think about, in terms of my little triangle here, if this is my theta, the opposite side is straight up and down. And that is, if I was trying to get to a point here, P, which is, say, x comma y, remember, I go out this much x and I go up this much y. So what we're saying is that the opposite side is the same as y. And then the hypotenuse we called r the other day. So we said this was r. So that's why we got y over r last class, right? So a week ago, we started with just opposite over hypotenuse. Then last class, we talked about how sine you can think of as y over r. Does that make sense so far?
Mm-hmm.
Okay. Same thing, cosine would be the adjacent. The adjacent is this distance here, x. So it would be x over r. Does that make sense so far?
Yeah.
Okay. On the unit circle, the thing that makes the unit circle is the distance of the radius, r, on the unit circle is always 1. So in this case, it's y over 1, which is just y, or x over 1, which is just x. So only on the unit circle is the sine of theta equal to y, and the cosine of theta is equal to the x value.
Oh, okay, I get it now.
Yeah, it only happens on the unit circle. Anything else doesn't carry over for. But just for the unit circle, then the sine value is the y value and the cosine value is the x value. Other questions? No. Okay, let's do a couple more. What about D? What about the secant of minus 315 degrees? So the first thing you want to remember is that the secant is the cosine flipped over, right? So this is going to be 1 over the cosine of minus 315 degrees. So if I'm looking for the secant, I really just need to find the cosine. Okay, and then yeah, we have 2 over square root of 2. So negative, what is the negative angle, right? Remember here, I have a negative angle. So usually I rotate this way around, that gets me positive. Negative means go the other direction. So if I'm going negative 315 degrees, this would be negative 90, negative 180, negative 270, and then if I go another 15 degree or another 45 degrees, I would get here, this would be negative 315 degrees. So negative 315 degrees, right here, and that is going to be, if I look at, so I'm looking for the cosine of it, so the cosine of it is root 2 over 2. So this is going to be 1 over root 2 over 2, which again, I need to make that look nice. So we're going to do keep, change, flip. So keep the 1, change multiplication, flip the bottom fraction, 2 over root 2. So we end up with 2 over root 2. Yeah, I can totally show how you went backwards. So basically, I kind of think about it. So from here to here, that's a negative 90 degrees. And then if I go another from here to here, that's going to bring me to negative 180 degrees, right? Because I'm doing 90 degrees. And then if I go another 90 degrees, that's negative 270 degrees. And then I need to go 45 more degrees, which brings me to that point there. So that's how I knew which spoke I was on. Does that help? No problem. Other questions? Okay. Let's do a couple more here. What about E? The tangent of 270 degrees. So tangent is what? What do we have to put on the top? Okay, -1. So tangent, remember, is y over x. So it's going to be a -1 on the top. And what would be on the bottom? Okay, a 0. So -1 divided by 0. So, can anybody tell me what is -1 divided by 0? Yeah, so -1 divided by 0 is undefined. You might have been like, oh, isn't that 0? So, when I think about division by 0, I call it Dr. Gorman's pizza math. So if you basically can have a number divided by 0, or you can have 0 divided by a number. So I think of the top of the fraction as being the number of pizzas, and the bottom of the fraction as being the number of people at a party, right? So this is pre-COVID days. This went over better, right? But if you think about it, over here, there's no pizza, and there's, say, 100 people at a party. So there's no pizza. Since there's no pizza, even though there's 100 people, nobody's getting any pizza, right? So 0 divided by some number, 0 divided by 10, 0 divided by 100, 0 divided by a million, 0 divided by 50, that's all going to be 0. The other side, some number of pizzas. So maybe there's 10 pizzas in a room and nobody's there, right? It doesn't make sense. Where'd the pizzas come from? Like, why are there pizzas in a room and nobody is there, right? A lot of stuff about it doesn't make sense. So that's the one where it's undefined, right? So my pizza math is just kind of funny. Oh, whoops. And I wrote the wrong thing here, right? You guys let me write 0. I meant to write undefined. I was saying how most people thought it was 0, but the answer is undefined, right? So -1 divided by 0 is undefined. It can't happen. Questions? No. Okay. Let me add in my unit circle again. And what do we have? We had E. Okay. F. The sine of 11 pi over 6. So what do we think the sine of 11 pi over 6 is? Okay, so we have -1/2. So, right, remember the sine is the y value. So I'm going to come here to the 11 pi over 6 spoke. I'm going to look at 11 pi over 6, and the y value is -1/2. So this is equal to -1/2. What about G? What about the cotangent of pi over 2? Oops. So remember, cotangent is x over y. So I'm going to go here to pi over 2. Here's my pi over 2 spoke. The x is a 0. The y is a 1. So this is going to be 0 divided by 1. And 0 divided by 1 is 0. H. The cosecant of 2 pi over 3. And remember, cosecant would be 1 over what trig function? So which trig function do I flip over to get the cosecant? Yeah, the sine. So it's 1 over the sine of 2 pi over 3. And so if you look up the 2 pi over 3, right, here's 2 pi over 3. The sine, remember, is the y value. So it's root 3 over 2. So this is going to be 1 over root 3 over 2. So we're basically just flipping that root 3 over 2. So it's going to become 2 over root 3. Questions? No? Anybody before we... It's all clear. Okay, that's good. Y is sine at the bottom. Okay, so sine's at the bottom. Remember, when we've been finding these before, right? If you remember, we did things like sine of theta was opposite over hypotenuse, and then cosecant of theta, we flipped that over to get hypotenuse over opposite. Flipping over, when you flip something, you're really just taking 1 divided by what that is. So flipping is the same as saying 1 over whatever it was. So when I'm looking for the cosecant, I'm trying to flip over the sine, and the mathematical like equation way of flipping something over is to do 1 over. So you could also just remember that the cosecant of theta is 1 over the sine of theta. The secant of theta is 1 over the cosine of theta. You can also have, just how we had before that the tangent was x over y, you also can rewrite the tangent as the sine of theta over the cosine of theta. And some of this is stuff we're going to get to after the first test. And the cotangent of theta would be the cosine of theta over the sine of theta. But these are helpful for us for right now when we're just pulling the sine and the cosine as the x and the y values off of the unit circle. Does that help? Other questions? That's a good question. No problem. That's what I'm here for. I'm here to answer questions, right? And so I can't see all your faces to kind of look at you and be like, I know you don't understand what's going on. So these, for right now, you don't have to have these memorized, but these are eventually, yes, you're going to have those memorized. But we're going to use them so often that usually you just kind of memorize them. So in terms of the unit circle, yes, you have to do the unit circle memorized. Other questions? No? Okay. So, I'm going to go to a new page, and I'm actually going to put down a couple copies of the unit circle, because I want to kind of show you something. And so since we're not in class, it's a little bit easier to show this like if I was live to you and could use my hand on the unit circle. And I can't, so that's why I'm going to like put down multiple copies of the unit circle to show you this next part. And then we're going to come back to doing a couple more of these types of problems. Okay, so we're going to do it one at a time. I'm just going to put the unit circle in.
Protractor.
So, okay. Whoops. Oh, there we go. That's what I was trying to do. I was trying to make it a little smaller. Copy. Paste. Okay. So when you're talking about the unit circle, right? And I kind of sort of hinted at this a little bit before, but you can look at the things that are related to 90 degrees. Oops. Not 90s. 90 degrees or the pi over 2s, right? So this spike here, this is 0 pi over 2s, right? I haven't moved at all yet. When I move up here, this is 1 pi over 2. When I move to this part, right, this is 2 pi over 2s. And that makes sense because the 2 over 2 would cancel and it would give us pi. And this part here is 3 pi over 2s. So, if we were going around and around the circle, we could count by pi over 2s. 0 pi over 2s, 1 pi over 2, 2 pi over 2s, 3 pi over 2s, 4 pi over 2s, right? So 4 pi over 2s would be the same as 2 pi. 5 pi over 2s, 6 pi over 2s, 7 pi over 2s, 8 pi over 2s, 9 pi over 2s, 10 pi over 2s, 11 pi over 2s, 12 pi over 2s. So I can keep going round and round on the pi over 2 spokes, right? Does that kind of make sense? How I'm like starting at 0 and then I'm just counting all those pi over 2s. Okay. You can do it for all of the angles as well. So the next thing is we have pi over 6s, right? So if I look at the pi over 6s are 30 degrees or pi over 6, right? So again, I could start at 0 pi over 6, right? 1 pi over 6, which is just pi over 6. I also can have 2 pi over 6, and 2 pi over 6 is just pi over 3. I can do 3 pi over 6s, which is just pi over 2. And I could keep going. So 7 pi over 6s, or I'm not. 4 pi over 6s, 5 pi over 6s, 6 pi over 6s, 7 pi over 6s, 8 pi over 6s, 9 pi over 6s, 10 pi over 6s, 11 pi over 6s. So those are all the pi over 6 spokes, right? So if I had to find something that was something over 6, I could just start counting off on all these spokes, right? So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, 13 pi over 6, 14 pi over 6, 15 pi over 6, 16 pi over 6. So I'm just going around on those spokes. So I'm showing you which things kind of go together, basically. And you might go, why do we care about this? Well, I'm going to do a problem here in a second that we're going to care about it. I could do the same with the 45 degrees or the pi over 4s. So again, 0 pi over 4s. Here's 1 pi over 4. Here's 2 pi over 4s. Here's 3 pi over 4s. 4 pi over 4s. 5 pi over 4s. 6 pi over 4s. 7 pi over 4s. 8 pi over 4s. So what I can do, the handout that I'm going to give you, so the handout I was going to put up there is actually just this picture. However, I can actually take these notes and make a PDF of these notes, so that if you want to be able to like look at these, have these 4 things to reference, I can do that. Does that answer your question, Morgan? Yeah, I'll do that. I'll put up under the like lecture recordings, I'll put up the recording for this class, but I'll also put up a PDF. So it'll be all of the notes from today, but like without the video part, if that makes sense. Other questions? No. Okay, and then I could also do the pi over 3s. Whoops. I can also do the 60 degrees or pi over 3s. So you've got this, which is 0 pi over 3, right? And then I have this one here, so 1 pi over 3. Then this spike, this is 2 pi over 3s. Then here we are at 3 pi over 3s, 4 pi over 3s, 5 pi over 3s, and then back to 6 pi over 3s. And so the pi over 3s, you can go around the same way. So you might go, okay, well, why do I care about any of this? Well, you care about this if you were asked something like the following. Like if I asked the sine of 15 pi over 4, right? So otherwise, you'd have to like convert 15 pi over 4 to degrees. And then you'd have to find a reference, figure out where it is, find the reference angle, make a triangle, find the reference triangle. So the stuff we were doing last class, and then convert it back. And so it's a mess. But pi over 4s, I happen to know about the pi over 4 spokes. So I just need to go 15 of them, right? So all I'm going to do is count it off to figure out. So here's my pi over 4 graph. So we're starting here at 0. So 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4, 14 pi over 4, 15 pi over 4. So 15 pi over 4 puts me back at this spoke here. And sine, we said, is what? The x or the y? The y. And so I know my picture's a little tiny, but the y value here is minus root 2 over 2. So this is just minus root 2 over 2. That's a lot easier than figuring out how many degrees, figure out how many times I have to spin around, where's that angle go, figure out the reference triangle. So all I have to do is pull off the y. Yeah, I can totally show how I counted 15. So I'm starting here at 0. So 0. And I'm basically each of these spikes. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Does that help? All right, let's try another one. So what about the tangent of 17 pi over 3? So remember, the tangent's going to be y over x, but we have to get to 17 pi over 3. So I'm going to go to my pi over 3 graph, and I'm going to have to count 17. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 pi over 3s brings me here. And again, I know my line went through the values there. But the y value is minus root 3 over 2. Divided by the x value is 1/2. So this is going to be minus root 3 over 2 times 2 over 1. So the 2's would cancel. So this would just end up being minus root 3. Questions? No. I'll actually show you here. So let me add this in. What I do on the tests is, I basically give you like a template, so it's a little different, right? Because we're in an online environment. So usually what I usually do is, I usually give out a blank unit circle like this and have people for the test fill in the blank unit circle first, and then like that's part of your grade. So I grade you on the blank unit circle, how well you filled it in, along with the other part of the test. This is a little different, right? Because it's COVID and we're all online, and when you go to take the test, you're going to be online. So probably what I'll end up doing is I will have this unit circle, and I might like say, I might call this point here point A, and then I might ask you to tell me, what values would go in there for point A. In general, do you have to draw the unit circle all perfectly and stuff? No. But you are going to have to, the first test, you're not going to be allowed to use a calculator on. So you are going to have to be able to either figure out what the values are, or be able to make yourself a rough sketch of the unit circle or something to help you be able to get what those values are. Does that kind of answer your question? And those ones with all the spokes, no, you don't have to draw all them. I put them there so that you guys can see what goes with what. But I generally am I have if I was asked the sine of 15 pi over 4 and I just had the one unit circle, I would be the pi over 4 spokes, those are these spokes, right? Because I know pi over 4 is 45 degrees, so it's every 45 degrees. And so these are the spokes I'm talking about, and then I would be able to I kind of just mark them on my, paper or on my unit circle, and can fill them out, or can use them to count, if that makes sense.
I have a question.
Sure.
So would I be able to create a unit circle just like my own during the test?
Yep, absolutely.
Okay.
Yeah, and that's what most people do, right? They'll draw, I've had people even just draw a rough circle, and then they're kind of okay, I know there's 3 lines in each thing, and then they put down what those points are, and then they use that as a reference for the whole test. So yes, you absolutely can draw your own unit circle during the test. Other questions? No. So all the problems you're going to get on the unit circle are going to be those ones we were just doing, these past 2 pages. So problems like this, right? Or problems like this, or problems like this. Yes.
I have one more question.
Sure.
So if you can go back, I think 1 or 2 slides.
This one or the one before it?
Yeah, right there.
Mm-hmm.
So if you're asking for the CSC,
mm-hmm.
whatever, could we have not homework, but a worksheet on the side with the answers on another page so that we can work on it before the test, just as extra practice?
Wait a minute. So before the test comes, I will actually put up a review sheet for you to practice on. Is that what you're asking?
No, extra practice right now, so I can start working on it, because that one I feel I'm gonna need a little bit more work on. So I wanted to know if you can create a worksheet so I can have extra practice and you put up the answers.
Yeah, so one of the things is your homework and Alex will make you practice this. And you can, in Alex, always go back and practice ones that you've already done. Do you know what I mean? Or no? Like, I can show you in Alex here in a minute. And yeah, you can access the book in Alex as well. So I can show you how to find practice problems for that. The review sheet, so like next week, we'll be doing the end of this unit. And I'll talk more about the tests, and I'll put up the review sheet at the end of next week. And so the review sheet, it's not like exact problems that are on the test, but if you can do the stuff on the review sheet, you can do the stuff on the test.
Okay.
But yeah, let me log into Alex and share. Give me a second here. And I'll show you guys how, if you want extra practice on any of the topics, you can get practice on them. So, just give me 1 second here to log into Alex. So the test will be from sections 4.1 through 4.6. So we've so far done 4.1 through 4.4. And so the rest of the test will be, so next week we're going to do 4.5 and 4.6, and 4.5 and 4.6 are about graphing. So that's when we'll get the rest of the stuff. Okay, so I'm going to share my screen here in 1 second. I just want to get to the part where just get past the part where you guys can see, like, I want to get into student view, and then I'll show you guys. I might need to reset my student view, so yeah, okay, give me 1 second. Okay, let me stop sharing my iPad, and then give me 1 second. Oops. Okay. So let me share my screen here. Okay, so you guys can see this, right? So I'm in Alex. Okay, so you'll see in Alex there's a bunch of problems like this, right? Just cosine 4 pi over 3, right? Or, you know, go to this if I had more practice. It'll give me another one. So the, you know, sine of minus 5 pi over 4. So these are all the types of problems, like those problems we were just doing. Once you finish an objective, okay, so like, you know, you're at home, you're starting your path, right? And so there's a topic that you have finished, but maybe you want to practice more, okay? The way that you can practice things you've already finished is if you go to this hamburger menu and you go to review. And so when you click review, it's just going to bring up everything in the course that you can review. But if you use this little arrow here, so if I use this, go down an arrow, and I can now go to the different sections. So like these topics that we're doing right now, these aren't due until next week, right? I wouldn't wait to do them, but you got to finish the stuff from 4.3 and 4.4 first. That's what's due this on Friday. So the 4.2 is due next week. And so if you click on 4.2 and you look for, it has a bunch of the sketching stuff, which is, but here, finding ratios from a point on the unit circle, right? Finding the trig functions, problem type 2. These are those ones. So here, secant of 330 degrees, tangent of 330 degrees. So even after you've finished a topic on Alex, you can still go back and practice a ton more. And it's not going to like change your homework score. So once you've cleared that topic on Alex, you've locked it in for your homework score. But if you want to go back and you want to just practice a ton of these sines and cosines, you can do this. And then Alex will right away check it and let you know, yes, you got it right, or no, you got it wrong. Does that help? So it's under the review. So this way you can have an infinite number of practice problems, more than I could write on a worksheet. And I'm probably actually, I'm going to go in and change this so that the only homework that's actually going to be due next week will be the 4.2 stuff. However, because we're going to do 4.5 and 4.6 all of next week. So 4.5 is going to take us more than just Monday's class. So that's why I'm going to change it so the 4.5 isn't due at the same time, just so that you guys are aware of that. Other questions? No? No other questions?